good afternoon, everyone. I welcome you to this wonderful platform. This is the mentor Hambir Kliman. Today we shall be looking at alkanes and organic chemistry. Now, a lot of people actually find this particular topic very difficult. But I'm going to simplify this particular topic using the data which you are able to see on the screen. Now, whatsoever explanation that I'm going to give, make sure that you put it to heart or you practice, and then you'll be able to find as many questions as you can under this particular topic. Give us a subscription. Make sure you subscribe to this particular channel. Follow us as we embark on producing content or videos that will help you under organic chemistry. And of course, if you want to register for personal lessons, this is our WhatsApp number. It's a +26077664046. Okay, so you can text us on WhatsApp and then we'll be able to respond to you. Now, what exactly do you have to know about the alkanes? Whatsoever I will explain right now is exactly what you should know, and that's all. You don't need to add more. Now, what does it mean when you say alkanes? Or let me say, what are hydrocarbons? Okay, so from the term hydrocarbon, hydrocarbon, that it's a two-worded word. So there is the word hydro, and then there is the word carbon. So this simply means that hydrocarbon is simply molecules or compounds that are composed of hydrogen and carbon atoms. So you're going to be having hydrogen and carbon atoms in these particular compounds. Now, under hydrocarbons, that is exactly where you are going to find the alkanes and the alkenes. So alkenes, of course, in our next discussion. So under hydrocarbons, today we shall be discussing alkanes. Now, the alkanes are the simplest family of organic compounds. They are the simplest family of organic compounds. In other words, whenever you're talking about organic chemistry, the start point should always be from your alkanes. They are hydrocarbons, like I mentioned. Why are they called hydrocarbons? Because they contain carbon and hydrogen. Okay? And at the same time, they have a single carbon to carbon bond. So they have a single carbon to carbon bonds. In other words, all their bonds in this particular family have single bonds. Okay? They form a homologous series with the general formula CnH2n plus 2. So whichsoever organic molecule or compound under the alkane family which you want to make, it will always fit in this particular formula. Why? Because all the alkanes, they belong to the same homologous series. Okay? Homologous series. Now, I want you to look at the pattern of this particular table that you are able to see on the screen. Methane. Meth, by now you should know that meth simply means one carbon atom. Okay, so meth is one carbon atom, and then the ANE is coming from the term alkane. That's the last part of the word alkane. So this one is methane. Okay, methane. How do you write methane using the formula? Remember our formula was Cn H2N plus 2. So this was our formula. So whenever we want to write meth, how is it going to be? Because meth is one carbon atom, so you're going to write your C, but you won't show your 1. And then you're going to have H, and then you're going to have 2, then 1 here, plus a 2. So this is going to be CH. 2 multiplied by 1, it's 2, plus 2, it's going to be a 4. That is how they wrote methane. Eth means 2 carbon atoms. You can do the same. You put a 2 here, where there is N, then you multiply it to be able to give you something like this. Prop means 3. So if you put your 3 where there is N, you multiply it to give you something like this. The same also butane. But or bat simply means 4. If you put in a 4 where there is N, it's going to give you something like this. Now this is actually very simple. This is the structural formula which I'll be able to show you how to write your structural formula of this particular compound. We'll start from meth. We write also there covalent bonding, and then we see how best it's going to be, because they can ask you covalent bonding. Let me also mention, because they may ask you a question, as you keep increasing in carbon chain, what happens is their temperature eventually starts increasing. So it was at negative 165. As you keep increasing in carbon chain, or as you keep moving from meth to earth, from earth to prop, from prop to bat, your temperature or your boiling point should start rising as well. Okay? That is very important for you to understand. Now, what are the key points that you should know about the alkanes? Number 1, they are found in petroleum and natural gas. They are found in petroleum and natural gas. Important multiple choice question. Which one of the following is natural gas? Natural gas is simply methane. Okay? Okay, sorry. This is methane. So, methane is simply natural gas. Okay? The first 4 alkanes, which is meth, eth, prop, bat, are gases. The first 4 alkanes are gases. Important multiple choice question. Which of the following alkanes are gases at room temperature and pressure? So make sure you know the first 4 alkanes are gases. Okay? The next 12s are liquids. The rest are solids. So just know the first 4 are gases. The next 12, meaning you start counting from the 5th, okay? From the 5th until to where the 12th is going to reach. Those are liquids. The rest will be solids. Third point, very important point, which I want you to understand. Now, since all their carbon-to-carbon bonds are single bonds, the alkanes are called saturated. Now, why are alkanes called saturated? Look at this. If this was, let's say you have butane. So butane is going to look like this. So hydrogen, 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 hydrogen here, hydrogen here. You also have hydrogen, right? Now, because there is no area where you are able to place another element or another molecule, if at all you reacted with something which we can call A can be anything. If you reacted this particular compound with A, there is nowhere where A can fit because it is already full. That fullness is what we are calling as saturated. Okay? Saturation. It can't receive any more extra compound or molecule. Okay? So because it has a single to single bond, okay, because it has a single carbon to carbon bond, alkanes are generally unreactive. So what determines reactivity? It is the bond. Because they are the single bond, they are unreactive. If they are the double bond, they would be reactive. Now look at this point again. 5, very important. The alkanes, they do burn well in a good supply. So these are the two formulas I want you to know. Put them at heart. In a good supply of oxygen, the alkanes will form carbon dioxide and water. So when you are reacting methane with a good supply of oxygen, you are going to produce carbon dioxide and water plus heat energy. Now this equation, make sure you know it at heart and how to balance it, okay? Now, at the same time, these same alkanes, they also react with little supply of oxygen or in small quantities of oxygen, but this time around they produce carbon monoxide and water plus less energy. So these are the two equations. Please make sure you pick these equations, practice them, know how to balance these equations, because they will ask you important question, especially section B. They will say, write the two formulas which are illustrating this particular molecule compound, meaning the given alkane, how it reacts with the oxygen in full supply, okay, or how it reacts with oxygen in low supply. They want you to illustrate the equation. So these are the two equations you need to illustrate. So in high amount of oxygen, you write that one. In less amount of oxygen, you write that one. Very important. Okay? Those are very important equations that you are supposed to know. What other thing happens to these guys? The alkanes undergo what we call substitution reaction. Please take note. They undergo substitution reaction. Now, substitution, what does it mean to substitute? To substitute basically means you are replacing something with something. In the first place, I mentioned that the alkanes are saturated. In other words, all their areas are filled with carbon to carbon atoms. They are filled with hydrogen atoms, and all their bonds are filled with hydrogen atoms. So the best way they are able to react with another molecule or another element is by replacing one of the hydrogen ions with another element. A very good example. This is methane. Methane is saturated, you see. All the bonds are filled with hydrogen. But methane is reacting with chlorine. So the only way a chlorine molecule can attach to methane is by removing one of the hydrogen there. So it's going to be like this. You have methane, right, reacting with chlorine. This reaction uses light as a catalyst. What is going to be produced is you are going to get one chlorine atom. You are going to replace it here. Okay? You replace it there. Then the hydrogen is going to, the hydrogen which was here is going to combine with the remaining chloride to form hydrochloride gas. This is a gas. This is not hydrochloric acid, it is hydrochloride gas. So this equation is called substitution reaction. Now, substitution reaction, important multiple choice question, where does it take place? It takes place in the presence of ultraviolet light or ultraviolet radiation. Okay? Now, how do you name the compound which has been formed? Now, remember, this remember what happened? We have this chloride attaching to methane, right? How are we going to name this? So you start by calling out what attached to this compound. So it's a chloro, right? It's a chloro. If it was bromine, we would have said bromo. Okay? Now, because it's chloride, we are going to start with chloro. Then we just put the methane. So it's going to be chloromethane. Okay? Chloromethane. Because we only have one chloride ion. If we had two chloride ions, we could have said dichloromethane. If three, trichloromethane. Four, chloride tetrachloromethane. Take note of this reaction, okay? So, this is a photochemical reaction, of course, because it is taking place in the light, okay? It is called substitution reaction, okay? So, it's very important for you to take note of that. Now, how about its isomers? How do you name the isomers? They can give you something like this. They can give you something like this. How do you write the isomer of, let's say, a given organic compound? They were given butane. This is butane because it has 1, 2, 3, 4 carbon atoms. But how come here they are calling it 2-methylpropane? Now let me show you what is happening. This is the butane, right? Butane. Then they remove this last part here. This last part, they remove it so that you have a compound which is going to look like this. Right? The last part was removed, so they put it here. This part that I have circled, they have put it here. Okay? Then they close up everything. Okay. Now, how do you name this compound? Simple. The first thing is, because you know that this is methyl. Okay? This is methyl. Whenever you see a carbon with 3 hydrogen atoms, it's called methyl. It's also written like this. This is methyl. So, count where the methyl is. This is carbon 1, carbon 2. So this is going to be 2 because that is where the methyl is. The methyl is on the second carbon atom. So you say 2 methyl. Then you count how many carbon atoms are there in a straight line. 1, 2, 3. So this is propane. So 2-methylpropane. And that is how they name this isomer. Okay? That's it. That is how you name this isomer. How about if it was like this? Let's say it was like this. Okay? The methyl is here at the far end of the carbon atom, right? How exactly is it going to be? Same. You count. So this is 1, 2, 3. So it is on the third carbon atom. So you're going to say 3-methylpropane. Okay? 3-methylpropane. If you had remained with 4 carbon atoms, it would be butane. That is how you name these isomers. Okay? So what are isomers? Very important question they ask you. Isomers are simply compounds with the same formula but different structures. Simple. Same formula but different structures. So what is an isomer? Okay, structures having the same formula but different, or let me say compounds having the same formula but different structures anyway. Okay, that is how simple it is. Now, how about if you have been given methane? So let's start with methane. For the sake of practice, So we're using the formula. So it's going to be in like this. So methane is 1, this is going to be 2, we put a 2 here. Meth is 1, so it will be a 1 here plus 2. So this is going to be CH4. Then, how are we going to write, this is its molecular formula. How are we going to write its structural formula? Of course, it's going to be CH here, H here, hydrogen here, hydrogen here. How is the covalent bond going to be? You're going to write your carbon here, your hydrogen here, your hydrogen here, your hydrogen here, your hydrogen here. Then you put this your carbon atom. Okay, then of this your carbon atom, this is going to be your. Okay, so you have your carbon atom there. Sorry. Oh no. I knew I was going to delete everything. So you're going to write your carbon, your hydrogen here, another hydrogen here, another hydrogen here, another hydrogen here. Then you put your X and a comma. Let me write something big so that you are able to see in case maybe they ask you to write the covalent bond. Okay, something big. So this is going to be carbon, then you put an X. So this is hydrogen. Hydrogen has 2 atoms because it's diatomic, so you need to write 2 there to make it balance, covalent bonding. So even here, then hydrogen, even here, then X, even here, then X is balanced. How about, let's say, ethane? So it's going to be CnH2n plus 2. So F is simply 2. If we put a 2 as 4 plus this is going to be 6. How are you going to write its covalent bond? So it's going to be like this. Going to have this carbon atom here with another carbon atom. Then you're going to write, it's going to be 1, 2, 3. Even here, 1, 2, 3. So this is going to be hydrogen, 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 and hydrogen. Then you do the same. A dot and an X balanced, 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 then a dot and an X. Then here, you're going to put 2 dots because these are molecules. Okay? These are molecules. The dot symbolizes the atoms that are being shared between carbon atoms. Okay, between the carbon. So this carbon, this carbon. So the molecules that are being shared between carbon atoms. The X is what hydrogen is contributing. So that is how you show it. So this is the covalent structure of ethane. Now, having done this, it simply means you can do for prop and but you can do these ones. So make sure you send your answers on 0777 66 40 46. Let me see what you're going to write. Just this, and you're done with alkanes.